pick a number between 1 and 100. What's the average result? 50, right? But what if we pick two numbers between 1 and n? What do you think the max is going to be about? Well, this is a problem that no mathematician knows how to solve. Just kidding. Every mathematician knows how to solve this. Okay, so the answer is the max is going to be about 2/3 of n. So let's see if we can do it here. So these are all the possibilities. Pick one number here, one number here. The chance of the max being 1 is very small, but the chance of the max being n is much bigger because just has one of the numbers has to be n. It doesn't matter what the other number is. And you can see here that there's about 1/4 of a chance that the max is going to be less than half of n. So those are some interesting facts. Now, what square would we have to pull off here to about equalize the chance that the max will be less than this I or greater than that I? And you just want this square to be about half the size of the whole square, so that's I squared equals half of n squared, and you can work that out. And the max is about 70% of n. Now, this purple guy here is about the kind of like a median, not the mean. So if we really want the expected of max of all these possible things, then we got to sum up the probability of the max being I times I over all the possible maxes here. So for example, if we want the max to be probability of the max being 4, it's about 2 times 4, a little bit less, over n squared. So 2i over n squared, and then we can pull out 2n squared here, and all we got to do now is sum up all these squares. So how do you sum up a bunch of squares? Well, here's a square, and here's a square, and here's a square. They don't look like squares yet, but maybe we can make them look like squares. Okay, and here's a square. So if we want to sum up these squares, we can build a pyramid by putting the squares on top of each other. And that's good because we know that a triangle takes up about half the square it's in, and a pyramid takes up about 1/3 of the cube that it's in. So if we come back here, we can replace that sum of I squared with 1/3 of the cube of n. And now all we have to do is simplify that guy and by crossing out some stuff, and you can see that the expected max is 2/3 of n. So that's pretty satisfying.